Hello and welcome again as we look at yet another multiple choice question for IB chemistry. This particular question is full of words involving no calculations and no diagrams. And this is very unlike most of the questions in the IB exam. But of course it's useful and highly recommended that we draw a diagram for this question. As we go about drawing the diagram, let's look at the keywords and apply them to the diagram. The keywords are in a sealed container at room temperature, which would be 25 degrees Celsius. The sealed container is half full of water. So let's draw that sealed container, half full of liquid water. And then the temperature of the container, which is 25 degrees Celsius, room temperature, is increased. Let's put a little arrow there for that. And left for equilibrium to re-establish. Which statement is correct when the equilibrium is re-established at the higher temperature? So 50% of the container is liquid water and the other 50% is gas. The first thing that you have to be aware of is if you condense all of this vapor here that's in this 50%, it's not going to give you a higher or an equal volume of liquid as this 50% of the container, because when this gas becomes a liquid, the volume becomes a lot less. So let's keep that point in mind because it's going to be very useful in figuring out the answer. So right now we have an equilibrium at 25 degrees Celsius. The container is half full of water. So what we need to know is that at equilibrium, the rate at which liquid goes into gas and gas goes into liquid, those two rates are equal, and this is what we mean by a chemical equilibrium. But as the temperature goes up, more liquid is going to have the energy to become gas. The amount of gas would increase slightly, and then a new equilibrium would be established with a little bit less liquid and a little bit more gas. So let's change this to about 28 degrees Celsius, the new and higher temperature. But does that mean that now we have more vapor than we have liquid? No, it doesn't mean that, because in the first place we didn't have an equal volume of water in the two sections, because one section was as a liquid phase and the other one was in the gas phase. And if we brought both of them into the same phase, both amounts of molecules, the liquid molecules and the gas molecules, if they were both brought into the liquid phase, then the liquid volume here would be a lot greater than the vapor that's up here. So with all of that information in mind, then we realize first of all that A and D have to be eliminated, because the rate of vaporization being greater and the rate of condensation being greater, neither of those are going to be true at equilibrium. And the question of course is saying which statement is correct when the equilibrium is re-established. At any equilibrium, the rate of one process must be equal to the rate of the reverse. So immediately we remove both A and D. Of course you started off with a container that was half full of water. And now at the new equilibrium, it's tempting to think that you'll have less than 50% water and more than 50% gas. But to start off with, like I said, it wasn't a 50-50 situation in the first place, because that volume of water that was in half of this container is not comparable to the volume that was in the liquid half. So therefore this statement is ambiguous, and this one is the only one that is valid. The amount of water vapor is greater than it is at the lower temperature, because one thing is for sure, at 25 you had a certain amount of water vapor. At 28 or 30 or any higher temperature, whatever that amount, it's going to be more than it was at the lower temperature. But the distractor in this question is saying that the container is half full, and that misleads the student to think that the volume of water in the vapor state and the volume of water in the liquid state, that those two volumes were equal. So therefore you might think that B is going to be a very strong answer with that reasoning, because you will say, okay, we began with 50-50 and now liquid is going to drop below 50 and gas is going to arrive above 50. But of course that would be leading you down the wrong track, because it's based on the assumption that if you have a container that's made up of 50% water vapor and 50% liquid water, that the two volumes are equal, and they're not. So the answer is C.